How are you, students? Now let's come to question number 7. So before we do this, I would like to recommend you to subscribe to this channel, and I strongly recommend you to share the channel to everyone so that students can use it properly in order to address their problem. So now coming to question number 7, it says change the matrix, this one 3 by 4 matrix, to row echelon form and a reduced row echelon form, and you are asked also to determine its rank. So the procedure goes like this. So the first thing that you need to do is you have to apply the different row operations so that you can have this sort of equivalent matrices. So you are having now here 1 4 9 7 0 0 3 1 0 2 6 minus 1. So let's now try to exchange row 3 and row 2. The reason why we are doing this is because we are having here two zeros, but in the case of second row, but in the third row we are having only 1 0. So we better bring these two zeros, you see, to be written, you see, in the last row. So we need to exchange row 2 and row 3 places. So this is actually swapping. So when we swap these two rows, the last two rows, the second and the third, we are having this one, as you see. So what I obtain here is equivalent to this one. Remember, students, that whenever we operate a matrix and get another matrix, the resulting matrix is equivalent to the previous one. Okay, so now look, we are having this. Now what we need to do is we need to create a mechanism where we can have, you see, 1 for the leading term. For that to come, let's divide the second row by 1 over 2, students. If I divide the second row by 1 over the second row entries by 1 over 2, I'm going to get 0, and this divided by 2 is 1, and this divided by 2 is 3, and here minus 1 over 2 can come. So this is clearly written on the right matrix, as you see. And here also we can divide this by 3 in order to make the leading entry to be 1. So when you divide, you see, the last row by 3, I can have 0 0 1 and 1 over 3. So here I wrote, here the second row needs to be changed by dividing its entries by 1 over 2. So this is the way it is written. And here the third row is to be changed by dividing the third row entries by 1 over 3. So the third row entries are now changed to 0 0 1 to 1 over 3, and here also the second row's entries are changed by, you see, half of the entries here in row 2, which actually are 0 1 3 negative 1 over 2. So dear students, this is in row echelon form, because as you see, the leading terms are, as you see, are here 1 1 1, and if you observe the zeros, the number of zeros here is 1, whereas in the row below this you are going to have, you see, 2 zeros. The number of zeros must be, you see, greater than the number of row zeros you are having in the upper row, I mean. So this is clearly written in row echelon form, so we changed this to row echelon form. Now what comes next is how we can write this in terms of what, students? In terms of row reduced echelon form, students. In order to change this to row reduced echelon form, we have to create a mechanism where we can make this for 0 here, because the leading entry in each column must be 1 as much as possible. Okay, the rest entries in each column should be what? 0. So here also we need to create a mechanism where we can make this 9 and 3 to be what? 0. Okay, these two must be 0. So for that to come again, we need to apply row operations. Other row operations shall be involved. Okay, so here we have, in order to change row 2, students, in order to change what? In order to change, look here, in order to change row 2, row 2 third entry, that is, let's change this, what, 3 to 0, students. Let's change this 3 to 0. To do that, what we need to do is we have to multiple, okay, we have to multiple the third row by negative 3 and add with the second row. Look, if you compare 3 and 1 here, students. If you multiply the third row by negative 3 and add that with, you see, this one, this turns to what? 0. What happens to the rest? The rest comes as they are, except this one. Look, in the case of this, when you multiply this one by negative 3, what is going to come here is minus 1, right? So when you add minus 1 with negative 1 over 2, it will be negative 3 over 2. That's why we are having here negative 3 over 2. So in order to change these to row echelon form, as I told you earlier, we have to create a mechanism where we can have this one to be 0, number 4 0, both 3 and 9 to be 0, okay? So here we are now changing 3 to be 0. For that to come, you have to create a mechanism where, you see, this can be 0, and this can be attained if I multiply the third row entries by negative 3 and add with what? 3. I have done this for the sake of having 0 here, okay? For the sake of having 0 here. But when I do that, I will again change this one, because I multiply this entries by negative 3 and added with what? Negative 1 over 2. And during this process, I'm going to obtain negative what? 3 over 2 as a final output. So I'm going to write that as it is. So here I got another matrix, students. So next, I have to create a means of making either 4 0 or 9 0, students. Okay, for that to come, I'm going to apply another approach. Look, I can now multiple, students, I can now multiple the second row, as you see, by negative 4 and add with what? 4. I can do like that. If I do so, the automatically what's going to come, the element which is obtained at the intersection of, you see, the first row and second column comes 0. Okay, this 4 can be 0, it can be changed. In fact, other entries can also change, no problem, you do like that too. What if I want to make this 0, student? If I want to make this 0, I'm not going to consider the second what? Row, because it doesn't help me. For 9 to be 0, I'm going to play now a game on third row. Here I'm having 1, so I will multiply this third row by negative 9 and add with what? This one, so that I can get minus 1 9 plus 9 to be 0. So I can now apply these two at the same time. But in order to show you how this can be done, I just have done this one by one. Let you see the following one. Look, now this is the row operation that is done in order to make, you see, the number 4 0, as you see. As I said, the second row is multiplied by negative 4. You see? Look, if you multiply the second row here by negative 4 and add with what? The first row entries, you see, you can obtain this one. Look, negative 4 times 0 is 0. 0 plus 1 is 1, as you see. Negative 4 times 1 is negative 4. Negative 4 plus 4 is 0. Look, I am multiplying the second rows of this matrix by negative 4, as you see. So when you come to this, negative 4 times the second row, it says second row, so we need to consider the upper matrix, okay? Negative 4 times 0 is 0, and 0 plus 9 is 9, so 9 is written, as you see. And negative 4 times what? Negative 3 over 2 makes 8 over 2. Yes, negative 4 times negative 3 over 2 makes what? Positive 6, sorry. And 6, students, 6 plus 7, because you are adding with R1 entry, 6 plus 7 makes 13. You see, guys? So, look, my intention was to make 4 0. Here I obtained 0. Still one step is left, because I have to create a means of making this what, students? 0. Because in the case of row reduced echelon form or reduced row echelon form, I have to get a column which actually is having leading entry 1, the rest 0. Here I have 1 0 0, here I have 1 0 0, here I have 1, but here I'm not having 0, so I have to create a means of making this 0. For that to come, I need to multiply the third row entries by negative 9 and add with what? This one, so that negative 9 plus 9 can be 0. Here also, negative 9 times 1 over 3 is negative 9 over 3, and that is supposed to be added with 13, so a certain result is going to be written. So expect that 13 is going to be changed. So what's going to come here is this. As you see, you can have this output. You see, guys, negative 9 times, you see, 0 is 0, 0 plus 1 is what? 1, as you see. Row 1 is being changed. The 1 to be changed is written to the left, as you see. So R1 is to be changed. It was actually 1, 0, 9, 13. Now you are having another output. So R1 is changed. So the 1 to be changed is written to the left. Now how is this changed? It is explained over here. change R1 in such a way that R1 entries should be added with the negative 9 times of what? Negative 9 times of R3 entries. So negative 9 times 0 is 0, 0 plus 1 is 1. Negative 9 times 0 is again 0, 0 plus 0 is 0, as you see. Negative 9 times R3 entry, which actually is 1. You see, negative 9 times 1 is negative 9. Now negative 9 plus 9, 0. This is a mystery why we multiply, you see, this 1 by negative 9 in order to obtain this 0. But as we are doing this, we do have also another output. Negative 9 times 1 over 3 is student negative 3. Agreed? So negative 3 plus 13 comes to be 10. So we are having this. Now students, look the leading entries. The leading entries in the first column is 1. So if you see the rest, you see entries in the first column, they all are 0. Here also the leading entry in the second row is what, students? Number 1. So if you observe the others, they all are 0. Come here, it is 1 again. So here also we have what? Zeros. So clearly this is in reduced row echelon form. I hope you have understood. What comes next is to determine what, student? The rank. The rank of a matrix is nothing, but it is what? The number of non-zero rows of a matrix after it is reduced to what? Either row echelon form or row reduced echelon form. No problem, you can take one of these two. So how many number of non-zero rows do you have here, students? Look, in the first case, you have here a non-zero row, one non-zero row. Here also another, you see, row which actually is having what? Entries different from 0. Again, different from zeros here. So you do have now 1, 2, 3 non-zero rows. Okay, non-zero rows. If you a matrix is said to have a 0 row if the entire entries in that, you see, row of the matrix is 0. Okay, here if you observe the first, you see, row, we're not having 0 throughout. Here also we were not having 0 throughout. Here also we are not having 0 throughout. So we do have 3 non-zero rows in this sort of what? Last matrix. The same is true in the case of row echelon form. Look, this is in a reduced row echelon form. If you come to this again, we are having 3 non-zero rows. So the rank is basically what? 3. So the rank of this matrix is 3.